Good day, everybody. Today we're going to start the last unit of the Cambridge Chemistry series, which is air and water chemistry. Now, this version of chemistry is arguably the easiest to see a direct application between our daily lives and the actual chemistry involved. This specific unit, we're going to be talking over the basics of air and water chemistry, as well as how human interaction with air and water changes things, and what we can do to keep them as safe and stable as possible. Now, the first subject that we're going to be talking about today is water. Water is arguably the most important natural resource that we have ever had to exploit or fight over. And we need to come, first of all, to the realization that almost all the water that we use on a daily basis is recycled. We're not pulling fresh water out of the ground for every single shower that you take or to wash dishes. Most of the water that we have is recycled. It's been used before, and we can clean it so that it's safe to use again. That's because, quite frankly, there's just simply not enough water for us to be wasting. States like California and Nevada right now are in a significant drought, or a time period where there's not enough water to meet their needs, and this is because they have overused their natural resource and are now paying consequences for it. California just enacted new laws against wasting water. Nevada has had laws in place for a while against doing things like watering your lawn, or you will pay a fine if you want to water your lawn or use water in a way that's not essential. So the concept behind recycling water is that used and dirty water can be cleaned using a three-step process that we call water treatment. And this is going to be the half of this unit is going to be talking about water treatment and the process that we go through with it. Now, the process is fairly simple. And before I get into the process, let's take a look at why we need to use it. This is a picture of Lake Mead in Nevada. Now, Lake Mead is the lake that's in the reservoir of the Hoover Dam, the largest hydroelectric dam that we have in the United States. Now, if you take a look at Lake Mead, the first thing you're going to notice is that the rocks around it, they've got black rocks up top and white rocks down below. And there's a reason for that. The water level that in Lake Mead where it should be is right in here where you see the blue line. Everything from here down should be full of water, but it's not. We have overused our water, and in this case, we have actually dropped the elevation of Lake Mead by over 100 feet, almost 200 feet. Something like 190 feet of water has simply vanished. And this is because we're using more and more water, and it's not being replaced by rain fast enough. So you can see over here, these things right here are what we call intake towers, and those should be almost completely covered in water up to about right here is where the normal level for the intake towers would be. These are massive. They're kind of like small skyscrapers when you get up close to them. So that gives you a real perspective for how much water we have actually used. So water treatment, and the focus of this section is going to be on the three steps. Step one is going to be screening, coagulation, and sedimentation. The reason that we do these things is because we can separate the bigger things that we don't want in our water, things like twigs, leaves, rocks, things like that. By using a series of large screens and then a chemical for coagulating them, we can get all these things separated out of the water so it looks more or less like water without anything large floating around in it. As soon as it's done with that process, we move it through what's called filtration. Now, filtration uses sand and gravel, and we basically force the water through this. And what this does is it separates out anything that would be smaller and made it through step one. So other small pieces of sand or dirt that might make it through. So what we get on the other side of step two, is more or less pure clean water, except it might still have some bacteria or microscopic things floating around in it. And then it goes to step three, which is called chlorination, where we use chlorine, which is the active ingredient in bleach, to kill off any bacteria that might cause disease or any significant health issues. So what comes off on the other side of chlorination then is just good, clean drinking water, and the thing that we can use in our homes and businesses. So the actual chemistry of water treatment that you need to know is that we use a chemical called aluminum sulfate. And aluminum sulfate, which is Al2SO4 3, makes smaller particles stick together. It's a substance that attracts these smaller particles together, and as they stick together and turn into kind of larger clumps, they become dense enough that they will fall to the bottom of the water, and we can skim the good water off the top. After we've skimmed the good water off the top, once again it's sent to that chlorination phase, and chlorine is lethal to just about every living thing. You'd have experienced that if you've ever cleaned off a kitchen countertop with bleach. Chlorine kills any bacteria in the water that might cause disease, and then we have to pH balance it, which means we need to adjust the pH so that it is pH neutral. And you'll hopefully remember that pH neutral means it's got a number of 7. And I've used water as the example for pH neutral a number of times. So after it's gone through all that extra chemistry, we consider it to be good and safe for public use. Now this is what the actual process looks like, and I would like you guys to copy this down into your notes. Water comes in on the left-hand side, you can see that right over here, and it goes through an initial screen. This screen is going to pick off the largest of the things, the tree branches, things like that. After it's gone through the screen, it goes into the coarse filter, and this is going to get the next size thing, smaller tree branches, larger leaves, things like that. In which case it then heads into the sedimentation tank. And this is where we start getting these smaller things out, the smaller rocks, pieces of dirt, things like that. After sedimentation takes place, it goes through another filter called the fine filter. This is the last level of things where we pull out anything that we don't want in the drinking water. After it's gone through all those different filters, it heads into a tank where chlorine is added. Once again, chlorine is this chemical that we use to kill off any living bacteria. And after the bacteria have all been killed off by chlorine, we can now store it in a storage tank. And it's going to sit in that storage tank until it needs to be used. The storage tank keeps everything clean and well monitored. It's also how we can make sure that the pH doesn't change by the time that it's called out and used for homes, factories, whatever we need our water to do. Now, I talked about the aluminum sulfate, and just to clarify, the aluminum sulfate coagulation happens right in here in the sedimentation tank. So it's right in here that we'll get those chemicals that clump things together and cause them to fall out to the bottom of the tank. Now, sometimes we need to test for the presence of water. In order to do that, we use what are called anhydrous chemicals. We talked about these during reversible reactions, and I just want to bring these back up. They change color depending on if there's water present or not. So in this first example, I've got a chemical that has been we've added a lot of water to it. By the time we get to step 2, this is what it would look like if it was dry. So if we heated this thing up and we boiled a lot of the water off, this is what it would look like. And then finally, we can use this now as a test for the presence of water, because if any water at all is added to it, you can see it changes to that nice light blue.